So let me see. I have to confirm my speaking language here on Zoom. Do I? Do you see this bubble appearing? Confirm your speaking language. That's interesting. Maybe it's going to transcribe. Right. So I have prepared some slides and I'm going to be showing you some slides and I'm going to be walking you through some concepts. But please really don't hesitate to raise your hand and ask me anything if you need further explanation, if you or if you want to add something from your perspective and your experience. People your age globally are naturally turning into really experts in advanced technology because you are some of the people who are using technology a lot and from a lot earlier than people our age are. So I'm confident that actually we can learn from you as well, not just you from us. So please don't be shy. I'm perfectly fine being interrupted during my presentations. So either use the chat or the raising hand function, or if I don't see the chat because I'm presenting, just say, hey, I want to say something. It's absolutely fine. Um, so I will start sharing my screen shortly. Just let me prepare the presenter view. All right, that should be it. So I'll be sharing my whole screen in case I have to run to another window. And here we go. Right. So you do see my screen now, I hope. So
Yes.
who I am? That's Maya. As Felicia said, I'm on the International Board of Directors of AMEC, the Association for the Measurement and Evaluation of Communication. In addition to this, I'm Director of Research and Insights of a company called Cometric. Cometric is an AMEC member, and it's a specialized media evaluation and insights consultancy. I've been working in this space for over 15 years now. And when I say this space, I'm saying broadly media intelligence, PR measurement, and communication impact evaluation. In my current role, I'm working very closely with our machine learning teams, and my remit is to work with them to embed AI in products, services, and internal operations that we have in the company. So this is why I have accumulated know-how on the topic of AI in media intelligence. I'm not a computer scientist myself, but I do have some background in academic research. I'm a PhD. I have a doctoral dissertation on social network analysis applied to news and social media content. So this is, again, not too far away from applied mathematics and computer science, but it is a communications field application of social network analysis. In a previous life, I used to work as a journalist and a policy researcher, but I'm definitely quite happy to be in the media intelligence industry, which I have to admit, when I was your age, guys, and when I was a university student, I didn't know that this industry existed, even though it was there. Um, so definitely, probably I would have jumped into the onto this train a little earlier if I knew it. Um, so today we talk about AI and MI, artificial intelligence and media intelligence. It's so much intelligence on one slide. I'm just becoming smarter by looking at the words. But of course, we mean intelligence in a different meaning in both of these phrases. So intelligence in the sense of artificial intelligence, right, is the brain's superpower to understand things, to remember, to ask questions, or to make smart choices. This is what we say when we talk about intelligence in that meaning, how well someone or something can think, learn, or solve problems. But then there is another meaning, another connotation of intelligence, and it is the connotation that we use in the phrase media intelligence. And it's similar to the way we use the term in military intelligence or business intelligence. And it's about collecting data from many sources, analyzing that data to find patterns and trends or important insights, and understanding what it all means in a way that helps an organization respond or plan effectively. So, in short, intelligence here means turning lots of media data, in this case, into useful knowledge. It is talking to, taking a flood of chaotic information and organizing it into something that is clear and actionable. But I do find it really interesting that we're using the same word in both artificial intelligence and media intelligence, even though in different meaning, because definitely it shows that there is a connection. And let's look into this. So first, I'm going to talk to you about AI and some key definitions and concepts and how some things work. And then we're going to go into how this is applied to media intelligence. So I'll start off with this visual slide. I'm not the best in designing, so sorry about my ugly umbrella. But I just really wanted to convey the meaning that artificial intelligence is an umbrella term. It refers to the development of computer systems that can perform tasks that would typically require human intelligence. And this could be things like learning, reasoning, problem solving, perception, or understanding of language. And under this term of artificial intelligence, we have multiple other terms, and I want to just put them out here, and we can just very quickly kind of define them. Please jump in if you want to add anything or if you have questions. So machine learning, this involves the use of algorithms and statistical models to enable computers to learn from data, from past data, and improve their performance on a specific time over time without being explicitly programmed. This is like giving you a bunch of books without teaching you how to read, but then actually reading them aloud so that you can hear what should happen, see the books, and learn how to read in this way. Obviously, we humans don't learn to read exactly that way, or maybe some do, but I think they're outliers and geniuses. But this is exactly what happens with computer machine learning. We give them lots of data, that is the training data, and we expect them to learn by themselves. Within machine learning, we have different types of learning. One is called deep learning, and this is a subfield of machine learning that uses so-called artificial neural networks. So basically, this is a model to solve complex problems, and we're going to get back to this because deep learning is one of the techniques used to enable current state-of-the-art large language models like ChatGPT and others that we know and use. Supervised learning is a type of machine learning and an approach to machine learning where algorithms learn from labeled training data and they have to predict the outcomes of unseen data. And this is something that now is commonly called in our industry classic machine learning. I love how we are so advanced that something that looked like rocket science a few years ago is already called standard or classic. Because this really is the way that most machine learning was happening over the past few decades. Basically, you provide the trained, tagged data, labeled data, and you use a statistical model to find the trend, the patterns, so that they can predict the result in a new corpus of data. So we have supervised learning. Naturally, we have unsupervised learning as well. And this is a machine learning approach where algorithms learn from unlabeled data. And basically, the algorithms are designed to discover the underlying structures or patterns within the data without being told what this means. How can you imagine it? Let's say you feed an algorithm with course papers by students, and you tell them these are papers that are graded excellent, these are papers that are graded medium, and these are papers that are not passing. And the model learns how to grade your papers based on already graded papers. This is supervised learning. In the unsupervised learning, you give the model multiple student papers without telling it which is a excellent grade, which is a pass grade, and which is not passing. And you expect the model to find it out for itself by, let's say, comparing that one of the documents is much more robust and in-depth than the other. So this should be graded higher than the other. Then we have, in my grouping, the fourth one is called reinforcement learning. And this is a type of machine learning where an agent or a model computer learns to make decisions by interacting with an external environment and receiving feedback in the form of rewards and penalties. If you have been curious about the development of ChatGPT and large language models, you know that this is the type of learning that is used there. Basically, the teams developing chatbots have been doing exactly this. They have been doing reinforcement learning, basically saying to the model, "You did good here. I like you," and or "You didn't do good here. You're going to be penalized, and I'm not going to use you anymore." And this is something that helps the models learn from this supervision, that from this reinforcement, that this is a pattern that is desirable behavior, and this is a pattern that is not a desirable behavior. Then I'm going to this brownish phrase here, NLP. I know NLP means other things as well, but in this case, we're talking about natural language processing. And this is the subfield of artificial intelligence that focuses specifically on enabling machines to understand, interpret, and generate human language. And I'll tell you why this is something that I'm putting out as something separate shortly in my next slides. Um, then computer vision is the subfield that obviously speaks for itself, that enables machines to interpret and understand visual information from the world, such as images or videos. Um, do you know how many of the models on computer vision are generating their training data? Do you have any idea? Any takers? So when you're browsing the internet, and when you're logging into something, have you ever seen one of those, boxes of 9 images, and then the captcha tells you, now point all of those that have a bus or all of those that have a traffic sign. And this is you and everyone else on the internet helping computer vision models train how to understand, how to see the environment. Um, because you have to label this snippet of a photo that it actually has a piece of a bus or it actually has a traffic sign. And then all of this data, imagine how many times a day you end up seeing this, or a week. And then imagine all of the millions and billions of internet users who are also doing it. So every day there's massive amounts of data being generated and fed to algorithms, and these specific algorithms are used for training computer vision for the purposes of autonomous cars. So be careful and always say where is the bus, because you want the autonomous cars that are going to be flooding our streets to know where the bus is. You don't want to mislead them, okay? Um, then I guess speech recognition, speech generation, again speaks for itself. It's that subfield that deals with the development of algorithms to convert spoken language into written text. So I think this is something that also Zoom has inbuilt, and many of the other applications. All of our phones have this as well. And it now looks and feels like something very, very standard. But only a decade ago, the speech recognition was so rudimentary that it was not able to properly um, convert, for instance, non-fluent, non-native English language to written text, while now current speech recognition models definitely do this. I'm going to very quickly go on mute and off camera. Sorry for this. I'm coming back shortly. Here we go. Okay. I hope it's not going to happen too much. So then large language models. Um, this is the type of AI model that focuses on understanding, interpreting, and generating human languages. So it's something that learns from all of these other elements, the NLP, the unsupervised learning, the recognition, the reinforcement learning. And they're trained on vast amounts of text data. So obviously, in recent years, they gained a lot of prominence because of their impressive performance. Sorry. So LLMs are based on machine learning techniques, and they are trained to learn patterns and make predictions and generate text. So they can generate text as long as they have been exposed to something similar during their training. So usually they use the deep learning architectures, such as transformer architecture, or we could talk about it a little later, and the so-called deep neural network, specifically designed to handle sequence data. Sequence data is sentences, for instance. Imagine it as sentences of words. So, way before ChatGPT, we already have long been exposed to AI technology that sometimes is quite basic. Think of it as you typing and the predictions you could see behind your typing, behind actually the software that you use to type on your phone or elsewhere. There is a statistical model. So the moment you type, let's say, TY, and assuming your setting is to English, the model would predict what is the likelihood, the statistical likelihood, for you to write any other character after TY. And the best bet is type. But that's something similar that's happening um, now, of course, much better when it's not just your next letter that is being guessed, but actually the whole phrase. Let's say when you're typing now in your phone, in your messenger app, you say, I had such a, and then basically the model expects you that you want to continue the sentence with great time, lovely time, because it has learned from past interactions. And then something similar with Google autocomplete suggestions. It works very similar, but actually it's not just based on guessing what your own next character would be, but also what many other people have been typing. So when I write Timo, then actually, and why I'm writing it, because I'm going to talk later on about Bob Dylan, and Timothy Chalamet just had a movie where he played young Bob Dylan. So this is why I was typing Timo, but then as you see, Timothy Chalamet comes only second here before the American historian Timothy Snyder. And this is the Google suggestion, which actually works in a very similar way. I know this is overwhelming. I'm not going to go through each and every step, but I really wanted to show you a simplified timeline. I think you might have seen many similar timelines about the development of artificial intelligence. So usually all of those timelines start around the 1950s. And this is around the time when researchers, computer scientists, also came up with the term artificial intelligence and came up with some a test. Then it says Turing here, but it has to be Turing, the Turing test. And the Turing test is actually what in computer science, but also in nowadays, um, is interpreted as the test for whether we have achieved artificial intelligence, and it's whether a model, a machine, can fool a human that it is actually human. And I think we might be seeing quite a lot of uh, instances where this is happening nowadays. Let's see how long I will have until the next one. Um, I have here highlighted two pivotal moments specifically from my perspective of someone using artificial intelligence application in the media intelligence industry. So natural language processing is a discipline that really started shaping up in the 1980s. So this is not new, and I'll tell you why, what type of natural language processing we consider old and classic. And then almost 10 years ago is the launch of transformer models. And this transformer models is really what made a huge difference in jumpstarting the revolution that we are now seeing with large language models. So how does the machine learning process looks like in very simplified terms? These are 5 basic steps to build something like a smart assistant or a language model. And think of it as training a robot to understand instructions or language. So number one is, of course, to get data. Let's say, grab all the info you can. This is where we collect all the stuff the AI will learn from. It could be text from websites, books, messages. It could be even images, labeled images, or labeled audio files. For instance, let's say you could teach an AI how to respond to pizza orders. So you can collect real-time messages like real messages like, can I get a large pepperoni? Or I'd like to order pizza for pickup. So you give all of the possible messages used by real people to order pizza. Then you go to step 2, which is called cleaning, preparation, and manipulation of the data, but it really means fix the messy stuff. Raw data is usually chaotic. It has, for instance, if you think of text, raw data can have typos, emojis, random symbols, all kinds of weird formatting. So what we need to do is remove the junk, correct spelling if they're misspelling, and break things into small pieces that the AI can understand. And we call them how? Any guesses? How we call the small pieces that the AI can understand? Have you heard of tokens? So tokens is the phrase, is the term that we use for breaking the smaller pieces of text that could be words or little phrases. So basically, think of this step as cleaning up your notes before studying. Then in the red hexagon, we're looking at the training model phase. So let the AI learn. Now we feed that cleaned up data to an AI model. And it starts to notice patterns like when someone says order, they probably want something. The word after large is usually a type of pizza. Or this is like basically giving the AI a brain and teaching it to read. It's kind of how you learned and I learned English by seeing and hearing it a lot. Then in step 4, you have the testing phase. And this is where you test how well your model was trained in the previous step. So you have to quiz the AI to see if it really gets it. Now you give the model some new examples that it hasn't seen. For instance, you say something that is in a new slang. Let's say you say, yo, hook me up with a medium veggie. And you check, does the AI know that you mean that you want to order a vegetarian pizza? If yes, then awesome. But if no, you go back to the drawing board, feed more data, clean it, and continue training. Then step 5 is basically the continuous phase, improving the model, making it better. This is where you tweak things, add more data, adjust settings. And if you have a reinforcement pattern, this is where you say you did good, you did not good. Um, and then you repeat the process to make it smarter and more accurate. So think of it really as a cycle, not a continuous line that, doesn't go back. How, however, a computer learns to understand language. This is something that is called the technology is called word to vector or matrix of meaning. So turning text to vector is like translating human language into robot language. So the robot can understand you and help out. Robots, computers, they're really good at handling numbers and handling binary logic like yes, no, or 1, 0. So let's say we have words like cat, dog, and banana, and we want to teach the computer to understand what they mean, not just the letters, but you want to understand the meaning, ideas like, and to test those words against ideas like animals, food, or pets. So what you do is, so what in computer science, what is done is there is a matrix where each row is a word and each column is a concept. So here we see the words and the concepts. And basically, you see how one word falls into those concepts. So cats are animals and pets, but they're not food. And banana is not an animal and is not a pet, but it is a food. And now you have a meaning matrix. So, and this is how it can be visualized in a matrix, as you see here. You see that banana is in one place and a completely different place, but together, grouped together, are cat and